It's Mr. Rator speaking here. Right, this is dedicated to my year 13s, who I think I've confused slightly with proving identities. So I'm just going to go through some of the examples for them, looking at how to prove these trig identities and hoping it will help them. So let's have a go at the first one. So what we got here is sine x plus cos x all squared. Prove that it's equal to 1 plus sine 2x. So the best way to do this is start with the left hand side. You get sine x plus cos x. And I'm going to square it. Okay, so I'm just going to put sine x plus cos x. So forget sine x times sine x is sine squared x. And then you get sine cos x and again we get cos sine x, which is the same as this, and then you get cos squared x. And if I put them together, I'm going to get sine squared x plus cos squared x plus 2 sine x cos x. Okay, now as you know from your year 12 identities, this sine squared plus cos squared, and make sure you tell the examiner that you know that sine squared x plus cos squared x is identical to 1, so there's your 1. And also let the examiner know that you know that sine 2x is the same as 2 sine x cos x, so that is equal to sine 2x, and that's what they require on the right hand side. That's QED as required. Okay, so let's have a look at B. So the first thing I'm going to say is when I see that, I think of difference between two squares. So what I'm going to do straight away, I'm going to factorize. I'm going to start with the left hand side. I'm going to factorize it. So I'm going to say cos squared theta minus sine squared theta. That's going to times cos squared theta plus sine squared theta. Now as soon as you do that, you realize that this again, because of our year 12 identity, sine squared plus cos squared is equal to 1, this is equal to 1, and you are timesing 1 by cos squared minus sine squared. Now that is the same as cos 2 theta. That's the same as cos squared theta minus sine squared theta. That's an identity. So I can just call that cos 2 theta. So when I multiply these two together, I just end up with cos 2 theta, which is the same as the right hand side, and again QED as required. Okay, let's do another one. So this one I think I confused a few of them. No, I think this one was okay. It's the next one that confused some of them. So let's have a look at this one. Now, again, what I'm trying to say to you guys is look for clues on the right hand side, what you need. So you need a cos 2a. Okay, so how I'm going to get that? I can say tan is the same as sine 2a over cos 2a. So that's coming there. Tan is the same as sine a over cos a. Actually, if you look at this, tan is the same as, remember, tan is the same as sine a over cos a, which I've just stated there. And as that gets divided by that, that in fact is saying I've got sine over cos 2a cos a. So let's have a look at this. So let's just do our normal fractions. Now the normal way to times fractions is x factor smiley face. So times those two together, times those together, and then times these together. So I just say to the GCSE students, x factor smiley face makes them laugh a bit. So if I times that over there, you'll get cos a sine 2a. If you times that at the top, you're going to get the minus between them, sine a times cos 2a. And times these two, the denominators together, you're going to get cos 2a cos a. Now I'm not going to change, I'm not going to play around with this because I know that in the answer I need a cos 2a. And I also need this cos a there. So I'm just going to play with the top. So from there, I'm going to, because I need to get rid of these and end up with sine a. So what I'm going to do is, I've got cos a, and I have no choice but other than replacing sine 2a with 2 sine a single angle cos a. Okay, so that is identical to that. Now, when I expand this out, I'm just going to put that all over this bottom denominator, which is cos 2a cos a. Now, if I expand that out, I'm going to end up with 2 sine a times cos squared a. So I need cos squared here. Now, the reason why I'm making a point of that cos squared a, because cos 2a, you got 3 different identities for that. So I want the one that has cos squared in it. So sine a, and I'm going to replace, now I'm going to just write it here because you should know this, that cos 2a, I'm going to use the cos squared identity in it, which is 2 cos squared a minus 1. So that's what I'm going to replace that with. So other than that, right, I'm just saying, yeah, so I'm going to replace that with this double angle identity. So if I put in 2 cos squared a minus 1. Now what that does is, it'll become a lot clearer on the next line. What I get is that times that, so like I said, I'm going to get 2 sine a, and cos times cos is cos squared a. And here, and I times that, I'm going to get minus, now I've got a 2 there, and I've got a sine a and a cos squared a, so I'm going to get 2 sine a cos squared a, and minus minus makes a plus. I'm going to end up with a sine a there. And that's all over cos 2a cos a. Now the beauty that happens here is these two cancel out because they're identical. Okay, so they're the same thing. And what I'm left with is sine a on top of cos 2a cos a. Now, as you know from here, that sine a over cos a is tan, so I can split that up and say I've got 1 over cos 2a times sine a over cos a. I'm going to replace that with tan, so that would equal 1 over cos 2a times, so that is, I just said here, it's just tan a. When I times that through, I'll end up with tan a over cos 2a, which is equal to right hand side QED. Okay, I'm happy with that. Let's move on. Obviously, anytime you guys want to rewind back and watch the video again, feel free to. Right, so this one where quite a few struggled. So I'm going to again start from the left hand side. I know one of my students preferred it from the right hand side, and can I just say that if you find either proving it from the right hand side, moving to the left hand side, or left hand side to the right hand side, it's 6 and 2 threes. Whatever you feel comfortable with, you go for it. Okay, so what I've got here, I've got tan. So I'm going to just put that tan over 1, so changing both of the fractions. And again, x factor, smiley face. Tan times tan is tan squared alpha. 1 times 1 is -1, and that I'm going to put 1 times tan is just tan. Now I like this because, I like this because I know that tan 2a, the identity to that is 2 tan a all over 1 minus tan squared. Now the reason why I like this because I can see that already. Okay, kind of seeing that almost already. The only thing now is you need to know some fraction tricks, what you can do. So what you can do in fractions, because I need a 2 there, I can times top and bottom by 2. So in effect, this is just equivalent fraction because 2 shared by 2 is 1, and if I times the fraction by 1, I get the same fraction. But what this trick does do is I don't need it over here, so I can leave it out on the top. So I'm just going to put tan squared alpha minus 1. But what it does is on the bottom, it gives me 2 tan alpha. Now that, actually if I put a bracket around the whole thing here now, is almost the same as tan 2a, but it's actually the reciprocal of that. Now one more trick I want to teach you at the moment. So what I can do is, what you could do is, if you take a reciprocal of something, it's just 1 over. So if I want to just quickly say that if I got tan alpha, tan 2a, and that is 2 tan a over 1 minus tan squared a, you can easily say that 1, if I put that all over 1, and what I do is by putting that over 1, it just flips this fraction. So 1 over 2a, 1 over tan 2a is the same as 1 minus tan squared a, all shared by 2 tan a. Okay, so you can easily do that. I mean, it's just like saying a fraction. If I had, I don't know, you can say a half, 1 over 2, is the same as, let's do another equivalent of this. Let's say it's a half is the same as 10 over 20. Okay, actually, why don't I say, let's just say what I said before. 5 is the same as 10 over 2. Okay, now if I say I want the reciprocal of 5, that is the same as the reciprocal of that. So if I take the reciprocal of 5, which is 1 over 5, it just is the same as flipping these over, so you get 2 over 10, and they're equivalent. Okay, so you can easily do something like that. That's the idea behind it. You can get the reciprocal, and you can just flip those over, because the reciprocal of that is 2 over 5. The two are the same. So that's what I'm literally going to do here. So there, I can now put this as, which is the same as 2. And I'm going to flip this over, which is going to give me, actually before I flip it over, I've got to do one more thing. So keep that in mind. I've got to just do one more thing before I flip it over, because at the moment I've got these two the wrong way round. Okay, so when I got these two the wrong way around, what I can do is I can multiply both the number inside and outside by a negative 1. So what I could do is I could introduce a minus 1 outside the bracket, and that will introduce a minus sign in there. So if I negate that, I will get 1 minus tan squared alpha. Okay, and that's all over 2 tan alpha. Okay, so that's a little trick I can use. I'm just said if I've got if I had 5 times 2, okay, now I've got 2 number signs there, I could easily say that's the same as minus 5 times minus 2. So I can just use a product and put a negative in both of them. So I'll put a negative there, and I'll put a negative in there. By putting a negative there, the tan squared alpha becomes a minus tan squared alpha, and the minus 1 becomes a plus 1 here. So I can switch to that. Now the reason why I've done that is because now I've introduced that negative, so I can able to flip those around. 2 negatives make a positive. So they both will give me, in this case, they both give me the same answer, 10. So by doing that, I know that this 1 minus 2 over tan a, 1 minus tan squared a, they're the same, okay, but it's upside down. So I can now use this fact, because this is the same as tan 2 alpha, but flipped over. So I'm going to write this as minus 2, and this is the same as the reciprocal of, like we said here, tan 2 alpha. Okay, and now once I've done that, I can just multiply the 2 in there, which gives me minus 2 over tan 2 alpha. And that is the same as the right hand side. Purity. So just a couple of things you need to play around with if you're not used to these little tricks, which helps you to get the reciprocal, and it also helps you to get 2 negatives. So you had to know 2 fraction tricks there to try to get you right hand side. Okay, let's have a look at another one. Now, to do this, so we need tan squared theta. So now, just in your head, think, what is tan squared theta? Well, tan squared theta is the same as sine squared theta over cos squared theta. Now, I know there's 3 different substitutions for cos 2 theta, and I'm going to use 2 of them. So I want to end up with sine squared at the top. So I'm going to use 2 of these facts. So at the top, I'm going to use cos 2 theta is equal to 1 minus 2 sine squared theta. And at the bottom, I'm going to use cos 2 theta, which is 2 cos squared theta minus 1. So I'm going to use that bottom. So if I start with the left hand side, I'll get 1 minus bracket. So I'm replacing cos 2 theta with this one, which is going to give me 1 minus 2 sine squared theta. Okay, and on the bottom, I'm going to get 1 plus, and I'm going to replace the cos 2 theta with 2 cos squared theta minus 1. So I'm going to put 2 cos squared theta minus 1. Now I'm going to get rid of the bracket, so that gives me 1 minus 1 minus minus becomes a plus 2 sine squared theta all over 1 plus 2 cos squared theta, and plus minus makes a minus 1. Okay, let's neaten this up. So what happens here is 1 minus 1, they cancel, and I've got 1 minus 1, so that's cancelled with that. So I'm left with 2 sine squared theta over 2 cos squared theta, and now I can easily cancel these two, because 2 divided by 2 is 1, I'll end up with sine squared theta over cos squared theta, which is over here, which I wanted, and that is the same as tan squared theta, which is equal to the right hand side, again QED. Okay, there's a few of those. I don't know if I put another one. I have put a couple more there, so I've got those, so that's okay. I hope you're okay with that. Some of the students wanted to see something like this. I'll quickly just run through, see if I can quickly do this one. So you want cos 3a in terms of cos a. So what you do is start off with cos, and you can put 2a plus a. So you're using your addition. So by doing that, you will say that is the same as cos 2a cos a minus sine 2a sine a. So this is addition angles. Now from here, because I want it all in cos a's, I'm going to replace cos 2a with 2 cos a, cos squared a, sorry, minus 1 times cos a. Okay, and because I've got no choice here, I have to replace this with 2 sine a cos a, and I've got sine a over here. Now if I multiply this out, I'm going to get 2 cos squared a times cos a. It's going to give me 2 cos cubed a, and minus cos a. If I times that out, I'm going to get minus 2 sine squared a cos a. Now don't forget, I can now use my year 12 identity there. So I can say that I know that sine squared a plus cos squared a is identical to 1. So I can just say that sine squared a is the same as 1 minus cos squared a. So what I'm going to do is I'm going to do 2 cos cubed a minus cos a minus 2, and I'm going to replace this with 1 minus cos squared a, and then I've got still cos a to multiply that outside. So let's just expand all that out. So I've got 2 cos cubed a minus cos a, times that out, so I'm going to get minus 2 times 1 times cos a, which is just minus 2. Actually, why don't I just times this out first and then I times it out? So 1 times cos is cos, put that in the bracket, minus cos cubed a, just to make life easier. Rather than doing 2 steps, I've times that by 1, I times that by cos, so I've got cos and cos cubed. And I'm going to just double those. So I'll end up with 2 cos cubed a minus cos a minus 2 cos a minus minus makes plus 2 cos cubed a. And if I collect all those together, I end up with 4 cos cubed a minus 3 cos a. And that is it. That's how the cookie crumbles. Now see if you can have a go at this yourself, see what you reckon. I mean, it's the same thing really, but again the idea will be to split it up, and the starting point will be tan in brackets 2a plus a. So I'll go about it that way. Okay.